extreme value theorem. We have seen that some functions have extreme values, whereas others don't. The following theorem, extreme value theorem, gives us a condition under which a function is guaranteed to possess extreme values. That means let's see. Extreme value theorem is telling us that if we have a continuous function defined on the closed interval from a to b, then this function attains always an absolute maximum value and absolute minimum value at some points in that interval. Looking at these three graphs, we can see the highest and the lowest point on each of them. That's the highest point, that's the lowest. Absolute maximum, absolute minimum, respectively. That's the highest, that's the lowest. That's the highest level, highest points, and that's the lowest. That's we can see that my green dots are representing an absolute extreme values. Now, another thing it's important to notice that some of the values, it happens to be at the endpoints, like this one, for example, and actually is just this one. And the other one, the extreme values, they happened actually at the critical points. We can see, which means they are also local extreme values. So now the point is to determine the absolute maximum and absolute minimum value of the function with this condition, of course. Before we do this, let's see that we have to keep this condition, which means function must be continuous function defined on the closed interval. If we're not satisfying this condition, then the situation is different. Function doesn't really have a highest or the lowest point. Looking at the first graph, that's the first graph, we can see function is defined on the closed interval from 0 to 2. From 0 to 2, we even have the values. However, function is not continuous and the maximum value doesn't exist. The maximum value is not 3 because we can see we do not have the value at that point. The second graph represents continuous function, however, is not defined on the closed interval. And the interval is open, and the same thing, we can't really detect the highest and the lowest point. That means please remember continuity. I can highlight this, continuity and the closed interval. And then we do have instruction in order to find an absolute maximum and absolute minimum value of the function. We have to find a critical numbers, and of course we will have the endpoints. That means now we have to find a corresponding value of the function at the critical points and the corresponding values of the function for the endpoints. Whichever is the highest is the maximum, whichever is the lowest is the minimum. And let's see. Example number 1. Find an absolute maximum and minimum value of the function x cubed minus 3x squared plus 1 on the given interval from 1/2 to 4. That means, first of all, we have to find values at the endpoints. Value for 1/2, value of the function for 4, and also value of the function at the critical numbers. I will put C at the moment. I still don't know if I have 2 or maybe 1 or maybe none. I will investigate. I'm just listing 2 of them. Okay. In order to find a critical point, we have to find the derivative. This function is definitely continuous function because it's polynomial. Domain are all of the numbers for this function. However, domain for us is just the numbers between 1/2 and 4. Okay, that means maybe I can remove this one. Okay, let's find derivative. Derivative of x cubed is 3x squared. Derivative of 3x squared is negative 6x and plus 0. For the critical numbers, derivative is 0 if and only if 3x squared minus 6x is 0. Let's factor out 3x. X minus 2 is 0, and the zero product property is telling me that the 0 is one of the 0 is 0 and the other 0 is 2. Okay, we do have 0 and 2. However, we're gonna check against the domain. That's my domain one more time, and 0 is not in the domain. That means I will not list 0. 2 is fine. That means the only number that I will use is 2. Okay, and I don't have the other. Okay, now just the arithmetic. Let's substitute these numbers to the original function and check whichever number is the highest, whichever number is the lowest. Okay, let's start. 1/2 cube is 1/8 minus 3 times 1/4 plus 1. Okay, 1/8 minus 6/8 plus 8/8. What it is just 3/8. I believe so, because this will be 1 minus 6, negative 5. 8 minus 5 is 3. Okay, 3/8. Then let's substitute 4. 4 cube is 64 minus 3 times 16 plus 1. 64 minus 48 plus 1. And the number is, I'm just trying to, 16 plus 1, 17. Okay, and 2. 2 cube is 8 minus 3 times 4 plus 1. 8 minus 12 plus 1, negative 4, negative 3. Okay, that's me now. I see that this looks like my lowest number. Let's say m will be the absolute minimum value, and this looks like a highest number, absolute maximum. Absolute maximum. Okay, the first question done. And I think I have a graph that we can see the highest point, 17. The level is 17, and the lowest point, it happened at critical point, we can see at 2, it's negative 3. And 0, we're not taking 0. 0 will be not even the highest or the lowest point. However, we're not including 0 because our interval was from 1/2, which is somewhere here, to 4. Okay, example number 2. If the function f of x is defined again as a polynomial, x cubed plus 4x squared minus 3x, find an absolute maximum m and absolute minimum m and absolute maximum, the capital M, of the function on the interval from negative 2 to 1. Let's do the same thing. This is our domain. That means domain is only the numbers from negative 2 to 1. We will find the value of the function from negative 2. We will find the value of the function at 1. That's the endpoints. And also at critical points. I don't know, maybe 1, maybe 2 of them. Let's find critical points. Derivative is 3x squared plus 8x minus 3. Now, for the critical points, I need derivative to be 0. Derivative is 0 if and only if 3x squared plus 8x minus 3 is 0. Now, this is quadratic function. I will try to factor out. This is 3. That means I need 3 and 1. 3 times 1 is 3, but I need a negative. I will put negative. 3 times 3 is 9, minus 1 is 8. Okay, and the zero product property is telling me that this is 1/3 and this is negative 3. Let's check against domain. 1/3 and negative 3, and 1/3 is fine, but negative 3 is outside. We're not gonna take negative 3. Okay, that means I will put 1/3, but I will not include the negative 3 because negative 3 is outside. Okay, let's find the values. Negative 2 cube is negative 8. Maybe I can use the red color. It's, oh, it's negative 8 plus 4 times 4, it's 16. Negative 3 times negative 2 is positive 6. 16 and negative 8 is 8. 8 plus 6 is 14. Okay, 1. 1 cube, 4 times 1, 3 times 1. 5 minus 3, 2. Okay, and 1/3 cube will be 1/27 plus 4 times 1/3 squared, which will be 1/9, 4/9, minus negative 3 times 1/3 is 1. Okay, and let's see what we have. 1/27 plus 27, this will give me 12, minus 27/27, just a common denominator. And we do have 13 minus 27, negative 14. And this looks like my lowest number. This one looks like my highest number. 14 and negative 14/27. Now, let's look at example number 3. Okay, for this one we only have to find absolute maximum value for the function x plus 1/4/x on the interval from negative 8 to negative 1/4. Function is definitely continuous function, and this is our domain. That means we have to find a value for negative 8. We have to find a value for negative 1/4, and also for the critical points. I don't know, okay, let's say we will have 1 critical point, but we never know, we have to check. Okay, let's check derivative. Derivative is defined, actually we can check. I was gonna say that function is not defined at 0, however 0 is not in our interval. That's mean no problem. Okay, derivative. Derivative of x is 1. Derivative of, I can copy 1/4, and then derivative of 1/x is negative 1/x squared. And this will give me, let's clear this nicely, negative 1/4x squared. And derivative is 0. Derivative is 0 if and only if derivative is 0. I will write this. If 1 minus 4x squared is equals to 0. Okay, let's get the common denominator. 4x squared minus 1/4x squared is equals to 0. Fraction is equals to 0 if and only if the top of the fraction is 0, because we can't divide by 0. And this looks like x squared is 1/4, then x is positive or negative half. However, positive number is not in our domain. That means only, I will take only negative half. I can write this down. X is positive half and negative half. However, positive is not in my interval. This one is fine. That means I'm not including this. Okay, let's do the arithmetic. Negative 8. Negative 8 minus 4 times 8, 32. And that means this is negative 8 and 1 over 32. Now negative 1/4. Negative 1/4 plus, if I substitute negative 1/4, I should have negative, but I can put this negative right away in front. Okay, that means I have 1/4 minus just 1. This is negative. Negative 1 1/4. Okay, and substituting negative half plus 4 times negative half, I will switch this sign right away. Okay, negative half. 4 times half is 2 minus half. Half and another half, negative, of course, is negative 1. Okay, that means it looks like the highest number, because all of them are negative, that means the highest will be the smallest of the absolute value, which is 1. This is my maximum. That's what they want. Negative 1 will be my absolute maximum. Okay, and I do have one more. Okay, let's see. The same thing, absolute maximum and absolute minimum of the trigonometric function. That means we have to find critical points and then the values of the function at 0, that's one endpoint, and the value of the function at pi/2, and critical points. Domain, of course, at the moment is just from 0 to pi/2, because function is continuous and defined on the closed interval. Okay, let's see. I need derivative. Derivative of sine of 2x is cosine of 2x times 2. Derivative of cosine of 2x is negative sine of 2x times 2. Derivative is 0 if and only if 2 cosine of 2x minus 2 sine of 2x is 0. I can divide both sides by possibly, of course I can divide by 2. I was thinking about tangent function. I can divide by 2 and then I can say cosine of 2x is equal to sine of 2x. And I will divide both sides by cosine of 2x. Of course, assuming that cosine is not 0. And then I have 1 and tangent of 2x. Let's switch the side because that's the way to. Tangent for what angle is 1? This is my angle. That's my tangent for pi/4 is 1. Then I can just solve for x. Dividing by 2 will be pi/8. And pi/8 is in the domain. That means my critical point is pi/8. Let's find the values, and the highest will be maximum, the lowest will be minimum. 0. Sine at 0 is 0, cosine at 0 is 1. 1. Substituting pi/2, 2 times pi/2 is pi. That means I can write it down. Sine at pi plus cosine at pi. Sine at pi is 0. Cosine at pi is actually -1. -1. Okay. And then pi/8, if I multiply by 2, I will have sine at pi/4 and the same for cosine at pi/4. Square root of 2/2, root 2/2, which means the final answer is root 2. And this looks like root 2 is the highest number and -1 is the lowest. -1 root 2. And I don't see that answer. Actually, I do. That's my final answer. Thank you.